It is, guys, the moment you've been waiting for, the last math lesson video. So, where I was kind of looking forward to it too. Now I'm kind of dreading it. But we're going to find the volume of prisms in different ways. We already did 2 ways. We did counting them. We have done the formula, length times width times height. Today we're doing a 3rd way, which we did yesterday as well. This lesson actually gets easier. It's when you find the area of the base and multiply it by the height. I'll show you what I mean, but let's do a practice first. Which prism has the greater volume, prism 1 or prism 2? Obviously you can't explain your answer, but go ahead and choose your answer. Well, prism 1 has the greater volume. If I calculate it by using the formula, 10 by 4 by 6, it's 240 cubic units. And prism 2 is 8 by 12 by 2. So that's only 192 cubic units. So if I asked you which one you would rather have filled up with candy, you'd want prism 1 because it's bigger. A school has 1 computer for every 17 students. If they have 714 students, how many computers does it have? You can tell this is an out-of-date question because we have 1 computer per every student, but go ahead and solve. Right, it's a division problem, so it is 714 divided by 17, which is 42. All right, I want you to look at this solve and share, and I want you to be as creative as you can. Rachel builds a prism that has a volume of 24 cubic inches. Tell me 5 possible length, width, height dimensions for her prism. So I can't get 3 numbers that add to 24. I want 3 numbers that multiply to 24. Well, I'm going to go easy here. I'm going to go basic math fact. I'm going to say, let's say the length of the bottom was 8 and the width was 3. Then what would the height be? 1, right? And these are in inches. I'm not going to go ahead and write the inches in every one of these because it gets crowded. But all right, so let's mix it up. Then let's take another math fact of 24. Okay, 6, 4, and 1. This is easier than you thought, right? I took the easy ones. I went ahead and wrote the inches anyways. Oh, how about another math fact of 24? 12, 2, and 1. Okay, I feel a little cheap using the 1 inches one. So let's get one that, can you come up with one that is not using 1 as one of the factors? Since 2 is prime, I'm going to look at this one here, and 2 is prime, I can't break that up any, but I can break 12 up into 2 different factors, right? I could say 12 is the same as 6 times 2 times 2, right? And 6 times 2 is 12, and then there's 24. Or I could go back up to my top one here, and I could say, well, 8 is 2 times 4, that's 8, and then multiply that by 3. That would give me 1. And of course, I know some of you are probably thinking, well, I could do 24, 1, and 1. Sure, you could. But those are 5 different ways to find a volume of 24. You just have to be a little creative. All right, how can you find the volume of a rectangular prism when the area of the base is given? So, Carrie needs to know how much sand will fill a rectangular prism for her science project. The area of the base is 56. The prism's height is 6. And if the volume is length times width times height here, and I've told you that 56 is the product of whatever the length and width is, because it's the area of the base. It is my length and width. So my solution will just be whatever 56 times 6 is. And when I multiply 56 times 6, I get 336 and we know it was in centimeters cubed. That's the third way to do it. We just found it gave us the area of the base. It already did length times width for us. It actually made finding volume easier. They write it as the area of the base, written with a capital B, times the height could equal volume. Don't let that trick you. It's the same thing you've been doing. We just don't know what individual dimensions were there. It's not relevant to solving the problem. But what if you did? What if in the example, what if I said make up dimensions to equal 56? What could it be? What could the length be? Or what could the width be? Well, the length could be 7, the width could be 8, and then that multiplied by 6 would be 336. What's another dimension? You think, how about 28 by 2 by 6? It doesn't look like it's a 28 by 2 by 6, but that would also equal 56. So there's other ways you could play with it. But guys, this is it. We're just still using the length, width, height formula. But what's happening is the book is now giving us the product, the length and the width. We're calling that the area of the base. So if the area of the base is 18, what's the volume? Well, the area of the base is 18. We're going to go ahead and multiply. That is already taking into account the length and the width. So the length and the width is 18. Now I'm going to multiply that by 7. And 18 times 7 is 126. And it's feet to the third power. Notice the area of the base is in the second power squared. Then we multiply it by feet again, so that's why it's the third power. Area of the base is 52 meters squared. So the area of the base times the height equals volume. Notice that B is written capital, and it's written capital for a reason, because it is a calculation. It is a formula for the area of the base, and that's why. Go ahead and solve that for me. (156 meters squared times regular meters would be to the third power, or meters cubed. Or you could have it the old traditional way. It doesn't matter. And then this way, it is length times width times height. And to me, 11's the length, 4 appears to be the width, 5 appears to be the height. But to solve it, it's a heck of a lot easier for me to say, well, 4 times 5 is 20. And 20 times 11 is 220 inches to the third power cubed. That's it. That's today's lesson, and that's your practice buddy. But I want to just tell you one more thing before we go on. Sometimes you are going to be solving problems where we say volume is additive, meaning you can add the two volumes together. We did this in the first lesson this week when you had the cubes and you had to count one side. Well, if the prism is drawn, and that looks so confusing with all those numbers, you just have to split it in two. And I have a little dashed line separating it into two already. So I would have to find the area of, the volume, of A, and then the volume of B. So let's go ahead. For B, I'm going to just draw in here, and that's what I would tell you to do. Well, B, I know it's 3 feet long, and it does appear to be 5 feet high, and it's 2 feet wide. All of those are in feet, and it equals 30 cubic feet. Okay, that's B. Now, it's really nice when I can use color. I'm going to go to A. This is too confusing here across my bottom because I don't know. The whole thing is 6, but it's just a part. So then I like to go look at the top. That one can give me better information, can't it? 4 by 3 is the area of the base. And in this case, it's the top. But guess what? The top matches the base. So 4 times 3 is 12. And then the height here is 12. So it's 12 times 12, or 144 cubic feet. But that's not the volume of the whole shape. The volume of the entire structure is additive. So I take the volume of A, 144, and I add it with the volume of B, 30, and the total volume for that shape is 174 cubic feet. Okay, so just know that you can do that. I'm not even making you do a whole lot of practice with that, but I want you to know that that is how you do it. So I want you to look at this one for me. How would you split it? And it doesn't matter how exactly you split it, because some of them have more than one way. This one has one pretty obvious way here. I would look at it this way, and I would literally draw on my sheet. And I would look for a side in which I had both the two-dimensional length and width, right? And in this case, I know it's 2 by 7. And then how far back does it go? Well, it's not labeled here, but I look at its matching or corresponding. Yep, and it's 8. So this first one is 2 by 7 by 8. So 7 times 8, I notice how I'm doing these two first. 56 times 2 is 112, and that is centimeters cubed. Now I'm going to go ahead and look at the top box. Well, this here is 5. I agree. I'm going to use a better color. Red will show up nicely. 5. And this height is 5, right? So I know it's 5 by 5. But here's another thing. How long is it? Well, it matches the 8, right? It goes the same length back as this. So 5 by 5 by 8. That's 25 times 8, which is 200 centimeters. Oops, I wrote 20 cubed. And I'm going to add it to the 112 of the bottom. And that equals 312 centimeters cubed for total volume. Does this 1 centimeter really come into play? It doesn't, does it? It's almost there to confuse you. You didn't need it, because I knew that this side was 5. If this whole thing was 7, and if this was 1 centimeter here, and this was 1 centimeter here, then I know this was 5. But it was already labeled up there, so I used that instead. I'm going to give you one to try on your own. Pause your screen, draw on it to see, and then tell me the total volume. How did you do? Well, there's 2 ways you could split this. You could split it by this little one on top, or you could split it this way down. I'm going to just do right now, I'm going to do the using the one I drew first, and we could show you the other way. So in red, I'm going to show you this top here is 2 by 6. You agree? 2 by 6. 2 by 6, and it's 4 feet high. Okay. Well, 2 by 6 by 4 equals 48, and it's feet cubed. So now let's look at the bottom. The bottom is 6 by 5 by 10. Oops. And that's 300 feet cubed for a total of 348 cubic feet. So I chose to do it this way. What if, oops, I'm sorry, I'm going to make your little cube. I'm going to try to do it the other way, and I don't have a good eraser on here. So what if I did it this way? Sorry. Okay. So what if I chose to split my shape long ways instead? Well, let's see how I would do. I know that the area here at the top is still 2 by 6, right? 2 by 6, but this time I'd multiply it by 9. 2 by 6 by 9. And that equals 108 feet cubed. Well, then I have to go to this front cube. It looks like a brick here, right? It is 8 long, 5 high, 6 wide. So 6 times 5 is 30, times 8 is 240 feet cubed. And guess what my total is? Ding, 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 ding. It doesn't matter how you slice it. No, but it really doesn't. Your volume, when you break up a prism like that, will be the same if you do the right calculations, okay? And that's why there's all those extra numbers there. I didn't need 9 in my first one up here when I did this one. I didn't use the 9, but I used it when I separated my prism up a different way. Well, guys, that's it. That's all I got for you. You're ready for that practice, buddy, and then doing the IXL and Nearpod practice. You have made my year beautiful. This will be a year I'll never forget. I wouldn't forget it anyway because it's been really special. You're such a special, great class. But this whole distance learning, and I want to thank you for all you've done.